Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Suds by Michael Lefkowitz, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 without repeats in every row, column, and box. A digit X in a circle indicates how many circles of the same color do not contain an X. There's also a colorblind version of this. I'm not sure, actually. I'm just going to click on it, actually, right now and see. So this is the colorblind version, where you have the circles are separated, specified by a letter too. So obviously all these are C's, these are B's, these are D's, etc., etc. And again, a digit X in a circle indicates how many circles of the same color do not contain an X. Okay. Huh. So that means if you had, I don't know. That's actually a very interesting rule set. I don't think I've ever ran into that rule set before. Well, okay, so say you had a 1 in one of these circles. Actually, does a 1 work? I don't think so, right? If you had a 1 in these circles, that would mean that oh, I guess it could be possible to be 1, right? But it has to be in a certain combination, right? But basically, okay, if you had a 1 here, that would mean that in the rest of the blue circles, which are the ones that I highlighted because they allow you to double click on it, you would have one circle of the same color which does not contain that X, which would be 1. But obviously, as you can see, this can't be valid because just by having these circles all in the same box, obviously there's at least 2 cells in blue that cannot contain the digit 1, which is obviously incorrect. So yeah, I think that's how that works, right? Okay, say you had, I don't know, 5, then this would be saying that all other 5 digits, all of the 5 blue cells would not have a 5 in it. And that's what the meaning of a digit in these circles is, right? It's very interesting, actually. I think I see some, yeah, I think I see some ways that this works. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so let's start with the blues. Well, there's 3 different digits in the blues. And each of those digits must add up to the number of circles that do not contain those digits. Since there are only 6 circles, the 3 unique digits must add up to, at most, 6. So therefore, it has to be 1, 2, and 3. Is that right? Let me think. If you had 1, 2, and 3, that would mean that there's one. That can't be right. So it can't be that's 1, 2, and 3. Um, can it be 2? It cannot include a 2 either, right? If you had a 2 in one of these cells, that would mean only 2 cells cannot contain a 2. Or 2 circles, 2 blue circles cannot contain a blue. But the problem is we already have 2 other ones here, right? And those 2 would have to be different numbers. And therefore, they would have to contain, they would say, like, if you chose random or just any numbers, right? Say 3 and 4. That wouldn't work. Actually, I think it has to be specifically be 3, 4, and 5, right? One is not allowed because that means every other digit in the circles would be 1 except for 1. But the problem is we obviously have 3 here. If you try 2, then these 2 specifically would have to be, but then this would be ruled out here, right? Either one of these 2 is a 2, and then one of these 3 would have to be a 2, and that's already 3 digits that are not 2. So therefore 2 is ruled out. You can't have 6, obviously, because if you have 6 in the blue, that would mean 5 other circles could not have a 6, but that's not possible. So it must be specifically 3, 4, and 5. So therefore, these are all 3, 4, and 5. The 5 has 5 other cells which cannot have a 5. So this can't be 5, this can't be 5, and this can't be 5 because one of these has to be a 5. The 4 has 4 other cells which cannot be a 4. So one of these is a 4, and one of these is a 4. Therefore, this can't be a 4. So that must be a 3, which makes this a 4. This means this is a 3. These can't be 3s. So therefore, this has to be a 3. So this 3 says that there are 3 other cells which cannot contain a 3, which there are. So it's this one, and this one. The 4 says there are 4 other cells which cannot contain a 4. And that actually works because one of these is 5 and we have these 3. And then the 5 says there are 5 other blue circles, which does not contain a 5, which works because one of these is a 4, these are 3s, and this is a 4. So that's how that works, I guess. One of these digits has to be a 1. And there has to be a 2. The green ones obviously cannot be 1. Because if the green ones were a 1, that would mean that 1 being there would mean there's only one circle which does not contain a 1, but we obviously have 3 here. If it's red as a 1 in one of these spaces, the problem is if one of these were 1, that would mean that there's only one circle that would not have a 1, but one of these cannot be 1, and one of these can't be 1, so that doesn't work for there. Therefore, the yellow must be the 1. So this must be 1, which means there's only one yellow which cannot contain a 1. So therefore, this must be the yellow that cannot contain a 1. So this is a 1, this is a 1, and this is a 1. That means the other 4 digits, other 4 yellow circles, cannot contain what this digit is, which must be 4 then, because this must add up to 4. So this is 4, this is 1. Obviously, the green ones cannot be a 2, So one of the red ones has to be a 2. Which means one of these is not a 2, and one of these is not a 2, which means the other red circles are all 2. So this is a 2, this is a 2, this is a 2. And then the remaining digits would have to be, I think, a 4, right? So this can't be 4. This is 5, which makes that a 4. No, it's 1, 2. So 1, 2. I think it's 5, actually. It's 2 and 5, right? So there's 1, 2, 3, 4, 5, 6, 7 red circles. And 2 cannot be in 2 of them. So that means 2 has to be in 5 of them, which means the rest of the digits that are not in it has to be 5. Well, this can't be a 5, and this can't be a 5, so these 2 must be 2, which makes that a 5 and this a 5. So the remaining digits are 6, 7, 8, and 9 along the green. Okay. Okay, how many green digits do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 is only in one circle, and therefore it has to be somewhere here. 8 is in 2 circles. So one of them is here, and then one of them is here. So therefore, this is 6, 7, 8, 6, 7, 8. 7 can only be in 3 circles. Okay, so this one specifically then has to be the 8, right? Because this is 6, 7, 8, and 6, 7, or 8, right? Because it cannot be 9. 9 has to be one of these 4. Because the other 9 circles, green circles, must not contain a 9. Similarly with 8, the other 8 circles must not contain an 8. But if this were an 8, one of these would have to be an 8 also. And we know there's already 8 here. So then that would mean there's 3 8s in the 10 circles. But therefore, there would not be 8 green circles which don't have an 8. Therefore, this must be an 8. This can't be 8. This can't be 8. This can't be 8. And this can't be 8. So these two form a 6, 7. These two form a 6, 7, and we have 6, 7, 8, and 9 here. So that means we have already 6, 7. There's 1 6 here and 1 7 here. There's 1 6 here and 1 7 here. There's 1 6 here and 1 7 here. Well, for the 6 to not be in 6 other cells, it has to be in 4 cells. We only have 1 here, we have 2 here, and we have 3 in these cells. Therefore, this must be the 4th. So this must be a 6, which makes that a 7, which makes that a 6. This can't be 6 anymore. And what about these? We have 1, 2, 3, 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cells. 9 circles, sorry. So obviously you can't have a 9 in any of them. What can they be, actually? This cannot be 1, 2. It could be 3, 4. It can't be 5. Can't be 7. So this is 3 or 4 specifically. It can't be 9 again because there are 9 purple cells. And if there was a 9 as a digit, it would say that there's 9 circles without the 9, but that would be including that 9. So therefore, there would only be 8 purple cells left, which don't have a 9. These can't be 1 or 2 or 4 or 5. This could be... So for the purples, what could they be? This can't be 1, 2, or 3. So this is 4, 5. Cannot be 6. It could be 7 or 8. This cannot be 1, 2, or 7. It could be 3, 4, 5, but no 6, and it could be 8. These again could not be 1, 2, 4, 5, so it could be 6, 3 with 6, 7, or 8. But this can't be 6, so this is 7 or 8, and this is 6 or 8. This cannot be 1, 2, 4, 5, 6, so this is 3, 7, or 8. This can't be 1, 2, 4, 8, or 6, or 7. Oh, so this has to be 3, right? This can't be 1, 2, oh, it could be 3 or 5. Right, the rest of the column, we have a 6, 7, 6, 7 pair in column 7, so the rest of the column cannot be 6 or 7, and this can't be 1, 2, or 4 because we see 1, 4 here and 2 here, and it can't be a 9 because we have 9 purple cells. This can't be 1, 2, 5, 6, so it has to be, this can't be 3 specifically. It could be 4. No 1, 2, 5, 6. It could be 7 or 8. This cannot be 4. It could be 3 with 7 or 8 also. Okay. How do we deduce this then? We have at least 2 unique digits. It could be more. Obviously, 8 works as long as it's the only 8 in the purples. Can you have 3 is the question. You could, potentially, right? You could have a 3 here, and then this could be 3. And then this could be 3. This could be 3. So one of this would not be 3, obviously. And then one of these two is a 3. This would have to be a 3, and this would have to be a 3. But that's all possible. Or this is 5. Well, already, this is 1, 2, 3, 4, 5, 6 circles that don't have a 5. So this can never be 5. So this has to be 3 then. So this is 3. Obviously, only one of these two can be 3. Only one of these two can be 3. Only one of these two can be 3. And this, therefore, there's 3 digits that are 3 circles that already do not have a 3. So the rest of the circles must be a 3. So this is a 3. This is a 3. This is the only one of these two that can be a 3. So this is a 3, which means this can't be 3. Therefore, this is a 3. So this can't be 3. And this has to be a 3 because it's the only one that could be a 3 here. Okay, so there's at least 1, 2, 3, 4, 5, 6 digits which cannot be these digits. Well, if this is a 6, then these also would have to be 6s, but that's not possible. So this can't be a 6. This must be an 8. So this is the only 8 amongst this, which means there's 1, 2, 3, 4, 5, 6, 7 other ones, which means these both must be 7. This can't be 7, so this is 6, this is 7. These can't be 7. Now we're just probably doing Sudoku. Where are the ones possible? One of the ones has to be one of these two. And it can be one of those 3. That means it's one of those 2. Cannot be here, cannot be here, or here. So this must be a 1, which means this can't be a 1. This has to be a 1. So the 1 is one of these 2. We're not sure which 2s. We have 2 cannot be here or here because of these 2s. And this can't be a 2, so this must be a 2. 2 can't be here or here because of these 2s, and it can't be here, so this must be a 2. Which means one of these is a 2, and one of these is a 2. So that's not helpful. 3s. We actually have all 9 3s, I believe. Yeah. 4s. This has to be a 4. That's the only one possible. This can't be a 2, so where's a 2 in row 5? It has to be here, which makes this a 9. So since this is a 2, we have 8 2s now in position. We know where the last 2 has to be. It has to be here. What about 4? 4 cannot be here in box 9, can't be here, therefore it must be here in box 9. This can't be 4. What is the only place for 4? In box 4, it has to be here. It could be either of these two, so we don't know there. It could be any of these two, so that's fine. This has to be specifically 5 or 8, but this can't be 5, so therefore this is 8, which makes that a 5. That means this can't be 8. Remaining digits here are 6, 4, and 9, but this can't be 6. So where's the 6 possible now? It has to be here. This can't be 4, so this is 9. This has to be 4 then. So this can't be 6. We have 1, 5, and 8 remaining. This can't be 1 or 5, so it must be 8. This can't be 5, so this is 1, which makes that a 5. What else do we have? This has to be 8 and 5. We don't know which one's which. This is 5 or 9. And this has to be 4 or 7. No, not 4 or 7. 6 or 7. And this can't be 7. So this is 6, which makes that a 7. So this can't be 7. We now have a 6, 8, and 9 triplet in column 5, which eliminates 6, 8, and 9 from the rest of the column. So therefore, this must be a 7. Remaining digits here are 6, 8, and 9. This can't be 6 or 8, so this must be 9, which forces this to be 6 or 8. This is 6 or 8. This has to be 1 or 4, but this can't be 4, so therefore this is a 1, which makes that a 4. This can no longer be the 1, so that leaves this as the 1. Remaining digits here are 7 and 9. We don't know which one's which right now. Remaining digits here are 5 and 9. This can't be 5, therefore this is 9, which makes that a 5. This can't be 9, so this is 5, which makes that a 9. This can't be 5, so this is 8, which makes that a 5. This can't be 8. This can't be 9. This has to be 6, 8, or 9, but it can't be an 8, so this is 6 or 9. We have a 6, 9, 6, 9 pair now in box 5, which eliminates 6 and 9 from the rest of the box. Therefore, this is 8. That makes that a 6, which makes that a 9, which makes that 6. The remaining digit now here is a 7, which means this can't be 7, so this is 9, which makes that 7. This 6 means that this is an 8. This can't be an 8, so this is a 6. Remaining digits here are 5 and 8, but this can't be 5, so this is 8, this is 5. Now we're just doing Sudoku. We have 7 and 9 remaining, so this is 7, this is 9. This is 6 and 8 remaining. This can't be 6, so this is 8, this is 6. And then we have 4 and 9 remaining, so this is 9. And that's a 4. It seemed pretty easy to me. I don't know. It felt easier than easy, but I guess I can sort of understand. Like you have to think about the logic of these circles, which cannot contain the digit, right? I don't know. It just seemed fairly easy for me. But I've done. I mean, there's the. Interestingly enough, this is kind of like the opposite of normal circle puzzles, and I'm very good at those type of puzzles because for some reason I can see those very clearly. This isn't quite the same, but they have similarities. So maybe that's why I think it's very easy for me. Because for me it's I don't know, it seems to be something that I can naturally grok, I guess. Anyways, I hope you grok this solution, and I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.